So for Lab 9, we want to wrap up our super elevation and look at our vertical alignments and assemblies and corridors. And so for this lab, we're going to be going back to this 3-bearing alignment that we started, I think, back in Lab 7. So to start with this lab, we need a couple of things we want to check. So in the previous lab, we had gone through and created horizontal alignments, and we had two curves, curve 1 and curve 2. And I just want to verify that you're using a file where we changed curve 1 into a spiral transition curve. So just looking at some of the notation that it creates, it's in a normal crown, it goes from a tangent to a spiral, and a spiral to a curve, then it's in a full simple constant radius curve, and then has the curve to spiral and spiral to tangent transitions. And you can see how it creates these views with the super elevation along the alignment and tells you what the slopes are. And then so verify that you are using the file that where you've changed to the spiral. And then the other piece is to make sure that your updated super elevation view. So when we changed that first curve from a simple radius curve into a spiral transition curve, it would have gone ahead and changed the super elevation to a straight line, and a step that we had to go through was to make sure that we reran that super elevation wizard. So if for some reason you don't see it looking like this, where it goes into the full super in and out for both curves, then you'll have to go and run that super elevation wizard. And just to remind you how to get to that, you would highlight the alignment, go to super elevation, calculate super elevation, and then this is that super elevation wizard. And so this is what you would run through to correct the super elevation view. So, so at this point, we should all be looking at the same thing. Okay, so I want to go ahead and get out of the super elevation manager. So looking at the alignment with these super elevation views, I had to put all the alignment labelings on the last time so that you could see these, but generally we don't show super elevation in this way. We use it, it's shown on plan sets by using the super elevation view or this table over here. So I want to go ahead and show you how you can change some of the station labeling. So if I have the alignment selected, be sure to select the alignment and not the alignment labels. I can right click anywhere and it'll bring up this menu and edit alignment labels. So this allows us to choose what we want. And also we could change our increment. Pretty standard is major stations at 100 and minor stations at 50. But this super elevation view is what's showing us those cross sections. So I want to go ahead and select that and then hit this red X. I want to get rid of profile geometry. This is where it would show me on my horizontal alignment where things were happening with profiles. Go ahead and leave that one on. I want to go ahead and get rid of the design speed. So if I hit OK, you'll notice it kind of cleans up the alignment view. So now we're going to move into the vertical alignment component so that we have our horizontal alignment all defined. So I'm just going to zoom extents so I can get out there. And the first thing that we need to do before we work in the vertical is to create a profile from the existing ground that we're going to build our design profile from. So this is a step that we did a couple labs ago for the Division Street project. But just to remind you how it's done, I would have that alignment, actually without it highlighted. I want to go to the Home menu and under Create Design, go to the Profile, and the first thing to do is to create a surface profile. So this is what's going to tie our horizontal alignment to our to our existing ground surface that we created in the very first lab. So this is where we select our alignment. We only have the one new road, but if we had multiple ones. And then we only have one surface as well, but this is where we tell it where we want to create the profile from. So it's going to default to the sort of beginning and end stations. If for some reason we wanted to create a profile that didn't cover the entire alignment, we could go ahead and overwrite and limit it. So I want to say draw in profile view. If I went through each of these by going next, there's a bunch of options about how the appearance of the profile is going to look. We're going to go ahead and use all the defaults, so I can skip directly to create profile view. It's going to ask for the lower left corner, so I just want to select a blank area. So it's going to start at our profile. This red line is the existing ground, so it's using the 3D surface that we created in the first lab, and we can see that the profile, the existing ground is has going up, and then it kind of goes back down. If we look at the contours, we can see the same thing. It sort of tops out at 135, and then it goes back down the hill. These blue vertical lines are telling me the beginning, the start, and end. So what I can see from here is that from this point to this point is where I'm in some sort of curvature. So this is curve 1, where I have the spiral transitions, then the regular curve and out, and then I'll get the other side as well. So anyway, it's just kind of telling us points where we have the various points of our alignment. Now that we have a profile space and we have the existing ground defined, we can go ahead and define what our design profile, what the road is actually going to follow. So we're going to use the existing ground as a guide, but this is where we actually use, our tangents and vertical curves and grade breaks like we talked about in class. So back up on the home menu, create design profile, and instead of creating the surface profile, we're going to use the profile creation tools. The first thing it's going to ask is which profile are we talking about. We actually only have one, but if I go ahead and select that, so it's going to use that. It recognizes that that profile was based off of the new road alignment. It will just call it whatever profile style or type and counter. I like to go ahead and overwrite these, and we're going to call it design profile. So some other things, it's a design profile. There are other types we could overwrite. It's going to go ahead and use the appropriate layer, so it's going to put it on the road layer under profile. It's going to either have no labels or a complete label set. So the big piece is to hit this tab up here and to do the design criteria. So this looks a lot like what we did for the horizontal alignment. We want to make sure we're using criteria-based design. Use the design criteria. It's going to default to the one that's in there, and so it's going to find the minimum K tables. So if you remember from class, the K tables, if we multiply the K factor times our algebraic difference in grades, it's going to tell us what our minimum length of vertical curve is. So we only have the existing Green Book, the AASHTO 2011 Green Book in here, but sometimes other agencies you may work for would have their own design criteria files, and those would be available in there. Okay, so we'll hit this. Now you may remember from the earlier lab when we defined the horizontal alignment, that's where we also told it we were using the 2011 Green Book, and we set the Emax, but it's in there that we set the design speed. So if I were somewhere down the line wanted to go back and change my design speed from 60 to 70 miles an hour, I wouldn't do that on the vertical side. I'd go back to the horizontal alignment and update it there. So I'm going to hit OK. That brings up the profile layout tools. This will look pretty similar to what we saw for the horizontal alignment. So we want to, instead if we just drew tangents, it would only do PVIs, point of vertical intersections, and it wouldn't put any vertical curves. By selecting the design with vertical curves, it's going to put the parabolic curves in there as well. So I typically want to start and end my alignment right at existing ground. This kind of makes a lot of the other features work better in the end. But so you can tell, when you hover over something, if my O snaps are on, if I get that hourglass looking one, it's going to give me a nearest. I want to make sure that I have the box, so the endpoint, so it's actually going to hover in and pick up that endpoint of the red line where it intersects the blue line. So to begin with, let's just go ahead and set it simply, with one PVI in the middle. And once again, I want to use my O snaps at the end and then hit enter. And so if I zero in on this, you can see that I have an outgoing, a second tangent of minus 0.82%, pretty flat, and an incoming grade of just a little under 1. So by hitting the grid view up here, I can see another view of it. So it's showing me my beginning station and my end station, and I only have the single PVI, and it'll show the station of that. It'll tell me the elevation, the grade in and grade out, the algebraic difference in grades. So the A factor is 1.81. I have a crust curve, and then it tells me how long my curve is, so it's a minimum length curve. It tells me a K value based on, right now it's setting it at 151, which is for minimum stopping sight distance. If I wanted to allow passing sight distance, I could change it. I could overwrite this to 357, and then it gives me some other information. So here it's pulling that information that we defined, the design speed, we defined it with the horizontal alignment. So like I said, if we wanted to change it, we would have to go back into the horizontal alignment, update that. So I'm getting these error values. If I look, I'll also see that I'll have them here as well. If I hover over it, it'll give me information about it. It's saying that I don't have passing sight distance is violated. Now, if you remember from class, we have to provide stopping sight distance at every point, but passing sight distance is not something. So it's just saying that this would have to be striped so that passing was not allowed. If I wanted to update it or to get rid of that, I would have to increase my K value here to 357. It would get rid of that. You can see how it flattened it out and changed the length. You can see the information at the beginning of the vertical curve, and then here's all my curve information. It'll tell me the K value that I used, the length of it. It also tells me the high point and the high point station by clicking on that. So this is a pretty simple vertical alignment. We only have the single PVI other than the beginning and end stations. But if I look in here, you'll see that the proposed centerline elevation is considerably higher than the existing ground. I can kind of hover over and get some station and elevation, so I can see just how far. So that this one, the existing ground is down at 123 feet, and the road is at 124, so I'm seeing about 4 feet of elevation difference, which is going to generate a lot of earthwork and kind of the side slope impacts. So oftentimes we'll kind of start with a pretty simple alignment, and then we'll go through and try to follow the existing ground a little bit better. So for this next step, we want to go ahead and put some additional PVIs. So if I go back up to the profile layout tools, you'll see that there's an insert PVI. So it's just asking me to, at what point do I want to break the alignment. If I hit enter, it'll put another PVI there, and so if I look at it, it'll just create a grade break, right? And so obviously the difference in slope coming into and out of would be the same, because I just put a break in a straight line. So what I want to do is just highlight it so I get this grip, and then go ahead and just bring it down so you can see how that creates a little bit better following those. I know I'm going to put a curve in there, so I'm going to go ahead and reduce it a little bit. I can also make changes with this one. I can bring it up, and everything's dynamic. It's going to be increasing these. Often, though, when I make changes to this, it changed to my grade coming into and out of, and now I no longer have passing sight distance. The other thing, you'll see that it created a new PVI, but oftentimes when we have a pretty minor grade change like this, the algebraic difference in grade is only 0.6. We can get away without having a vertical curve, but we're going to go ahead and put one in, just so mainly so you see how they work. So in order to add a curve to it, I would go over to the curve icon, and we can either make it sort of what they call fixed or floating, where we define a particular point it has to pass through. A free vertical curve is just going to use the tangent information, and so we want to make sure it's parabolic. We rarely use a circular curve in vertical roadway design, but it has that option. So it's going to first ask for the incoming grade, then it's going to ask for the outgoing grade, and then it's going to ask for the length of it. So we'll go ahead and hit enter. So it just uses the minimum value, and then we're going to use the panorama window to fix everything. So this is a sag curve as opposed to a crest. So instead of stopping sight distance, it's going to use headlight stopping sight distance. So if I want to ensure that I have that, I need this value to be something greater than 136. I'm going to go ahead and make mine 138. Remember, there's a tendency to really build roads at these minimum values, and we're trying to be a little more proactive about safety and put higher values in here. If I want passing sight distance, I need it to be greater than 360. So you can see that it got rid of some of them, but I still have one outstanding one. If I go and hover over that, it's actually telling me a maximum curve length. So if you remember from sag curves, we were concerned about headlight sight distance, comfort, drainage, and appearance. And so this one is saying we're not meeting drainage. So in this case, we're not going to worry about it because we're actually don't have curbed roads. We're just going to have lanes and shoulders. So we're going to go ahead and let that error or that warning message stay. Okay, for the cross sections, I'm going to go ahead and get out of that and zoom out a little bit. So cross sections in Civil 3D are called assemblies. So back under Home, the Create Design, we'll see Assembly. We can create an assembly. So we can call it whatever we want. Often assemblies are used on multiple alignments, so we typically tend to call them something, not so much the alignment name, but something to do with the geometry of it. So a 2-lane section versus a 4-lane, or 2-lane with center lane, or something like that. So we'll say this is a 2-lane road with shoulders. So we're going to use all these default ones, and just note that it's going to go ahead and put it on an assembly layer. So it's asking for just a blank spot where we're going to build this assembly. We hit that. And so what it does is it's creating this sort of target to build our cross-section from. And so this red line represents the center of our assembly, or the center of our road. And if we look at it with a target, this point right here at the very center of the target is going to follow both our horizontal alignment and our vertical alignment. So everything's going to be built off of that. So the easiest way to build assemblies is to use what they call a tool palette. So back up at the Home menu, there's a little icon up here called Tool Palettes, and it's going to bring up typical objects that would be in our cross section. So we have all the curbs and barriers. There's different types of lanes, shoulders, medians, all those types of things. So this is what we're going to build it from. Okay, so the use of these defined objects to do your assemblies has a lot of benefits for calculating quantities, so how much pavement or base or subbase material would be needed. Um, so there's a lot of properties associated with them. Not all of them are objects that can follow a super elevation view. So we want to make sure that for our lanes, instead of using a basic like shoulder or basic lane, we need to use a kind of a more advanced one, and this lane with super elevation. So travel lanes using lane super elevation slopes. So these support the rotation that's required for your tangent runout and your super elevation runoff. So if you were to select a basic lane, it would remain static and it wouldn't follow a super elevation table. So we want to hit that. So the first thing we do is we just sort of build it off of there. So we're going to see, and it has a fair amount of layers. These are all things that can be defined, like a wearing course, the various top courses of your asphalt, and then your base material with that. So if we want to create another one, I'll just hit it again, and then it will move over to that side. So that's what gives me a lane in each direction, and now I want to add a shoulder. And so shoulders, you may, for those of you in a pavement design class, you might have been spending some time about whether the shoulders full depth asphalt or how they taper. We won't get into it too much, but we're going to use a shoulder extended all. And so it's asking us, where do we want that shoulder to match? Do we want it to match down at this layer, at the top of this layer? But we're going to go ahead and have the top of our shoulder match the top of our pavement. And you can see that the shoulder is going to have we're extending all of our pavement layers all the way through it. And then it has the taper on the side. And if I go over here, I can put the other one. So now I have 2 lanes, 2 shoulders. And then the last thing I want to do is create my side slopes. So this is what's going to allow it from this point out here on either end is going to be defined by what we set our cross slopes at and the width of everything. We need a part that's going to go and find the existing ground. So it's going to create a ditch, and so in some cases we may be in fill, and it may need to create a slope that's going to match wherever the existing ground is in this direction. Other cases we're going to be in cut, and it would need to go up in this direction. So a basic side slope cut ditch is going to be an object. We're going to tell it to start at this point. So it's either going to be a cut slope or a fill slope depending on where the existing ground is. And then we have one on that side. So when we bring in these objects for assemblies, they're going to have a lot of default properties. If I go ahead and double click on this, I can bring up the properties tool and we can see some of the information that's contained in the properties for this element. So a lot of it is, how it's displayed and some of the data part. But these parameters are the things that we're most likely going to change. So if it's kind of highlighted, light gray, it's something we can't change. It's just telling us information about what the default values are, but these are where we can override it. So it's showing us that we have a 12-foot lane, and it's sloped at a -2% away from the center line. I could also set my pavement information, it's showing that I have, it's in feet, so that looks a little bit strange, but 0.08 feet for the 2 different pavement depths, the wearing and the base asphalt course, base depth, sub-base, right? And so I can change, it's showing, our 12 inches and are 4 inches. And so if I update this according to my pavement design, then a lot of the quantities works when I'm trying to estimate how many tons of asphalt would be done, and I could create quantity tables pretty quickly from that. For ours, we're going to leave our width at 12 feet and our slopes at 2%. I'm going to just hit escape a couple times to get it unselected so I can select my shoulder. So I see some of the other information with this. These are all the defaults. For this case, we want our shoulders to be 3 feet. And so it's also saying it's going to slope at 2%. A lot of times our shoulders are sloped at higher than 2%. We may use 2% and then maybe 3 or 5% just to get additional drainage part of it. And then the daylight part is the 4:1, so it's setting what this part, what these look like. We're going to go ahead and leave that in there, but it's saying that we're going to get an additional 5.4 feet of sort of effective pavement width because of that taper on the side. So I'm going to hit OK, and then go ahead. I can get out of this one and change this one. So if you have two things highlighted, you get this varies. That happens a lot. You can only, if you want to change parameters, you have to make sure you have one selected at a time. So 3 feet. So the last piece of the assembly that we have to do is we selected our objects, the lane types, so that they supported super elevation, but they don't inherently use super elevation unless we set the parameters. And so you might have seen in the earlier one, it just says super elevation is supported. But down here, we actually have to tell it. So I've got the lane or the shoulder selected, so I want to go ahead and tell it, yes, I want to use super elevation. And then hit enter or escape to get out of that. I want to go ahead and tell it to use this shoulder and say supported and to use super elevation. So one of the things with the various lanes is it will ask, so it says, oh sorry, down here we want it to use super elevation, and then it's going to ask, what is it? Is it the left outside shoulder, the left inside shoulder? So this outside and inside is more, you can have a left inside shoulder if it's, if there's medians and whatnot. So for our case, we have, so this one is highlighted, it's on the right, it's the right outside shoulder. So that's set. So we set it to right outside, and we had this at yes, and then down here I think we only changed it in one place. We want it to use it. This is going to be the left outside shoulder. Because we don't have medians, we don't have inside, like if this was just part of a road and then there was a median, we could have, it being inside versus outside. Everything we're going to have is going to be the outside, and it's either going to be left if we're on the left of center line or right if we're on the right of center line. So we have that. Now for the lane, we want to set use super elevation, yes. So this is the lane, this is the right lane outside. So we have that set. And then the last one in here is we're going to use the super elevation. And it's going to be the left lane, outside lane. So, and then that's going to allow it to rotate according to where we're at with the tangent runout or the super elevation runoff. Okay, so I'm going to zoom. So we have our horizontal alignment, our vertical alignment, we have our cross-section defined in our assembly, and we have our super elevation view, which is going to define how we're rotating to go into and out of super elevation. So the piece that's going to link all this together is the creation of a corridor. So back under the Home tab, corridor, I just want to hit that icon, and it's going to create a corridor. We're going to go ahead and call it the new road corridor. And this is the piece where we tie everything together. So we just have a basic corridor style. It's going to put it under a corridor. Most, in this case, is we have alignment and profile. There are some sort of hydraulic or water resources where we might use feature lines, but okay, so we only have the single alignment, but here, this is where we would select whichever alignment we had if we had more than one. And then we have our profile, and probably one of the most common mistakes that we make in creating the corridor is we have this existing ground surface and this design profile. If we select the existing ground, what it's going to do is it's going to attach the assembly to the red line as opposed to the blue line. So it's going to follow the existing ground, right, and all of its sort of undulations up and down, versus attaching it to the blue line, which is our vertical alignment with our vertical curves. So we want to make sure we're selecting the, I called it design profile, you might have called it something else, but we want to make sure that we're using that and not the existing ground. So this is where we select the assembly. So we're going to say we're going to use the 2-lane road. It's telling us exactly what that assembly is. This is that description we put in. And probably the second most common thing after attaching to the wrong profile is forgetting to set this, and this is the target surface. So when we defined those assemblies and we put the cut and fill ditch, it was going to go find the existing ground, but it actually needs to know what it's trying to find. So in most cases you're going to use the existing ground. Sometimes we have another surface underground that might be, it needs to go find the, I don't know, the bedrock or some other piece, where we have multiple surfaces. But this is where it needs to know that. If you don't put that in there, those ditches won't even be created. It won't have anything that it's trying to target. So we'll hit OK. And so it brings up another view. And this is a view that you don't see that first view of the corridor except for the very first time you create it. And so this is the more common way of seeing it. But I could go, and change. If for some reason I picked the wrong alignment, I had picked existing ground instead of design, I could change it here. Probably the most common thing that we use this view for is if we have assemblies that change. So maybe somewhere along the line we were going to go from a 2-lane road and we were going to add a passing lane, so maybe we went through to a 3-lane section. And so instead of using that assembly over the entire, from the beginning to the end station, we might define a second assembly for some component to it. It's also selecting the frequency that it's going to create a section at, so it's going to look at a 3D view of this every 25 feet. I'm going to hit OK. And then rebuild the corridor. So if we go back and make changes to anything, to the alignments, the horizontal alignment, the profile, the assembly, any of that, we'll always want to rebuild this corridor. And so it's going ahead and doing all that. And so it's creating all these section lines. So if I kind of hover over it, I'll see that this is my crown point. This is the end of I have my 2 12-foot lanes, and then I have the various layers that are coming out. So paving 1, paving 2. This is where these are intersecting with the pavement taper, and then this is the end of my base, and then I have my daylight as my sub base is coming out. So all my pavement layers, my base layer, sub base, and then I have some ditches. I have in and out. Anyway, it creates all these different components where I have a break to it. I want to point out it's also the corridor over here on the prospector menu. It shows this new road, and if I were to make changes on anything, I would get a yellow exclamation point over here that tells me that I needed to rebuild. And all I have to do is right click on it and I can hit rebuild. Sometimes students want to hit rebuild automatic so that they don't have to remember to do that step, but it really slows things down, so I would caution against that. So depending on where we're at with cut and fill, it's creating kind of different this outer line is where it sort of daylights in. So let's go ahead. So we're kind of looking at it right here at station 24. If I highlight the corridor and go to section editor, I get a view that's going to show me what's happening in the cross section, the profile, and the horizontal alignment all at the same time. Up here it's going to tell me what station I'm at. If I look closely, I'll see this white line. That's actually telling me, it's right here too, it's telling me which section I'm at. So as I move forward, it's kind of slow, it's going to update all of those views. And you can see how that white line goes. So I want to go, I can also just go and select it. It's doing it every 25 feet. If I head back there in that corridor view, change it to 50 feet. It's also going to tell me, give me some unusual ones whenever I have like a PC or PT or VPC, VPT. It's also going to do a section there. But let's go look at 24 because that's what we were looking at before. So I can zoom into this, right? And so it was creating those lines at any of these points where my various pavement layers sort of came out on the taper. And then this is one where I was in cut. So this is the point where the ditch would start. And so it's either going to go try to find the existing ground. Well, whenever I'm in cut, instead of creating and just creating a line that came up into here, it's actually creating a ditch because you don't want water. If I just had a V-ditch, I would be having my drainage channel right at the toe of my pavement slope, which is allows a lot of erosion and of that pavement layer. So it's a sort of a smart element that says anytime I'm in cut, go ahead and create a ditch and then come back up with it. If I look at it at the other side, I have the same thing. It's creating that ditch. So that's what happens when I'm in cut. So it creates those drainage channels. And then I'm trying to remember, I'm just going to kind of keep going. And so now I'm looking at a point up here. Looks like I'm at station 28 plus 75. In this part, at this point, I'm in a fills section, so it's just going to find that daylight line. And so it tells me where my offset, that I'm 25.3 feet off of center line. Remember, I have a 12-foot lane. I have a 3-foot shoulder to here. I have my shoulder taper, and then I have my, what we call this, the daylight line, the point where my engineered section intersects with my existing ground. So I can see that. The other thing I want to point out is that now I'm in my curve. I'm actually coming out of it. And so you can see how I've super elevated, right? I have it. I'm at 7.8, right? And as I kind of move through, it's going to start rotating, right? You saw how that rotated. I'm going to back up just a little bit so you can use this to really view how your road is sort of coming into and out of super elevation. So now I'm back at my 2% crown because I'm on the tangent component to it. And if I kind of move through it, you'll see that I start to rotate the other way. And I'm moving into and out of super elevation. Okay, if I just hit close out of this section, it gets me back to my normal view. So another piece that we want to do before we drive the corridor is create what's called a corridor surface. So we have all these components to it, the horizontal, the vertical, the super elevation, the assembly, and we've defined all those with the corridor. A corridor surface actually creates a three-dimensional model similar to what we did when we created the existing ground surface from these contours. So what we want to do is go back and find our corridor over here on the prospector menu. So we have our new road corridor. If I right click on it, I can hit properties, and so this brings up all the information about it. This parameters tab, this was the one we were looking at before. If you ever want to get back and make changes with your assemblies or how things are defined, this is where you would go. But back here there's surfaces, and so this is where we define that we want to create a three-dimensional model, and this allows us to get elevations from every point within the corridor. So as opposed to just having sections taken every 25 feet, we would know exactly what the proposed ground surface would be at every point. So pretty useful for drainage and other kind of modeling things. So the first thing we do is we say we want to create a corridor surface. This just gives us I guess like a database to put these things in. And then there are two different types of data elements that we create the corridor from. One is lines and the other is links. We'll go ahead and start with the links. So we're going to go ahead and add the top. So it's saying the top of the overall corridor. We could set it at various pavement layers if we wanted to. We can also, if you look at feature lines, you can set the crown line. The most common one we use for feature lines is when we have something where we have a vertical element, like a curb face or like a wall or retaining wall or something. But we're going to use links to also add. So we have the top, and we're going to put daylight in there. And then we'll go ahead and put the crown. So we'll have daylight and top from our links and crown from our feature line. And then the other part of it is we want to go ahead and set the boundary. So instead of it creating a really large surface, we want to define it so that it's only going to go within the daylight line. So if I right click on this, I can say add automatically, and I want to hit daylight. This prevents it from trying to interpolate across, especially when you have curves. It might try to take a point over here and then kind of, use the like a chord line from it. And so this just sets that boundary, and I'm going to hit apply. It's going to rebuild the corridor. So if I go back over under surfaces, now I have my existing ground, but I also have a new road corridor. So it has a different kind of icon. I can tell it's a corridor surface. So one of the things that comes from corridor surfaces is proposed contours. So I have my existing ground contours, right? But now I can see that these contours, right, I have a full three-dimensional model. If I go ahead and I'm going to show a different view of it under, instead of showing it as contours, if I show it as my tin lines, you can see, it's creating, remember, it interpolates between all these points, and that's what creates the three-dimensional surface. But the most common one to show it is to show it as contours. These are considered design contours as opposed to background. So usually our existing ground we call background, and our design, it just makes them a little bit bolder. So you can see the contours are moving around and in and out of the ditch, and then they'll match up with the existing ground contours. So it just lets us know at any point as I hover over, because I have a surface, it'll tell me what the elevation is at that point. So it's just showing that I'm at 114 and just 115 and so on. Okay, so now that I have the surface, the last piece that I want to do is I'm going to go ahead and highlight the corridor. What's hard is it's sometimes hard to pick the corridor. It'll want to pick up on the surface and all kinds of things. I know when I have a corridor highlighted, I get a corridor menu, and the last piece of it is to go ahead and drive the corridor. So it's asking for a feature line. You can pick the center. I want to follow the crown. So this is telling me what I want to follow with my sort of vehicle. And so it puts me in a three-dimensional, and then I can select what speed I want to go. I'm going to go ahead and drive it at 40 miles an hour. I might want to set it to 60 because that's the design speed. It also tells me where my sort of eye height, it's going to put my eye height at 3.5 feet. And then, it's different sort of drive parameters. I'm going to go ahead and hit play. And so we're going to see what's happening so you can see what's going on with your cut and fill slopes, right? All the various, I can see my shoulders, my shoulder ditches, what's happening with the center line. And the big point I want to see here is that we finally get to truly visualize that super elevation transition, sort of moving in and out of the road. So we can see I have some kind of floating objects. These are, looks like these are my contour labels, right? They're kind of at weird ones. They're sort of at strange elevations, so they're sort of following along. But you can see how that road is sort of banked in and out. And then it'll reach the end. So with that, this is kind of the last piece that we were going to do. I'm going to go ahead and close out of the, so I let it catch up, close out of that one, and I get back to my regular view. So this is the last piece that we're going to do with this sort of fictitious project, and then the rest of it is going to be with our Division Street. But the reason why we wanted to do some in here is that Division Street is such an urban project, and so we don't have super elevation. We don't really have much interesting in terms of vertical alignment as well. So this project allowed us, this kind of lab project allowed us to visualize some of the stuff that we were learning in class. So with that, all you have to do is email me your drawing and you're done. Thanks.